Hi everyone. Today we are going to discuss about graphs. I'm in this video I am going to give a overview about graphs and its representation and also a traversal technique, either it is DFS. Okay, I will discuss about DFS. Basically, what is graph? Okay, what is graph? What does graph mean? Graph is a data structure. Graph is a data structure which has some nodes and edges which are interconnected to them, which are interconnected within them. So that is graphs. So basically graph is a data structure which contains some nodes and some edges. So this is a node and this is edges. So it is set of nodes and edges. So that is what basically a graph means. So this is an example of graph. So this 1, 2, 3, and 4. These are nodes and this arrow little thing, this is edges. So now there are basically two types of graphs based on edges. For example, so this is one and let's suppose this is two. Okay, and another one is this is one and there is a direct arrow in it. Okay. What's the difference between these two, you may ask? So the one without any arrow here, it is called as undirected graph. It is called as undirected, and which is directed through the graph is called as directed. It is called directed. So in this graph, we can see that in this graph, here 1 can travel to 2 and even 2 can also travel to 1, but it is not in this case. So 1 can travel to 2 but 2 cannot travel to 1 using the same path. So this is one difference for directed and undirected graph. Now there are another types of graphs also. So you may see some graphs having like some number represented here. For example, let's suppose this is 4 or something like, let's suppose this is x. Okay, what this x means is, so this x is the cost. Let's This is called as weighted graph. So this is called as weighted graph. What does this weight mean? You can, in simple language, you can assume that this is the cost for 1 to go to 2 or vice versa. So it is the cost for 2 to go to 1. So this may be the case, or if it is y in this case, so 1 should give cost y to travel to 2, but 2 cannot do that because it is an undirected graph here. So basically this is what the basics of graphs. And now coming on to the representation of graphs. So this is an example of weighted graph here. So this is an example of weighted graph where each edge is represented with some weights, some numbers, that is 6, 4 random numbers. So these are weights basically. So this is a weighted graph. Now there are two ways to represent a graph. So that is, one is adjacency matrix. So let's keep this side. Okay, this is adjacency matrix. Okay, wait a minute. Okay, in this case, okay, let me copy this thing also. Okay, this is a graph and this is the representation of it. It is taking so much time. Okay, okay, so this is the graph and this is the adjacency matrix representation. Basically what this means is, so what they did is to represent this graph in a matrix form. So they took it. So first what they did is they counted the number of nodes present in that graph. So that is 1, 2, 3, and 4. 4 is the number of nodes present in this graph. So they constructed 4 by 4 matrix. That is 1, 2, 3, and 4. 1, 2, 3, and 4. 4 by 4 matrix. Okay. And now whenever one is connected to 2, that cell 1 comma 2 is marked as 1. If 1 is marked in that cell, it denotes that it has connection from that this this element to this element. So it is for directed graph. You may ask, what if it is undirected graph? So one here, So let's suppose, let's take a small one, 1 2, and wait a minute. Okay, what if it is in undirected graph case? So let's take this itself. Okay, so we have to construct 2 by 2 matrix. So this is 2 by 2, is 1 comma 2, and this is also 1 comma 2. So now as we constructed 2 comma 2 matrix, so we can see in this graph 1 comma 1 and 2 are the connections. So 1 can also go to 2. So what I will do is I will mark 1 comma 2, this cell, basically this cell as 1, and I can also see that 2 can also go to 1. So I will do this thing. So basically what's the difference between this and this directed and undirected is, in undirected we will do this. If 1 comma 2 is a connection, we'll mark 1 comma 2 cell as also 1 and 2 comma 1 cell also 1. So if this is u and this is v, we'll mark, okay, if this is u and this is v, we'll mark u comma v as 1 and v comma u as also 1. So this is what the thing is, difference between directed and undirected. Okay, and there is also a thing called self loop. If there is a self loop, one can go to one, so it is basically not used. And this is one form of representation, that is adjacency matrix. Now I will come on to the adjacency list. Okay, adjacency list representation, this is the most likely and most used type to demonstrate the graph representation. So basically in C++, that is, this is vector of vectors, and in Java that is array list of array list. So what we will do is, so as we will make a vector, we'll make a vector of suppose any data type, let's suppose int, and we'll mark an array of adjacency, let's suppose adjacency lists, let's name it as adj, and n, this is the size. So what n means, n is basically the number of nodes present in that graph. Okay, so what we are doing is, okay, let's take this itself, wait a minute. Okay, okay, in this you can see, we will, what this does is, this will make an array of n. Okay, okay, this is an array of n. Let's suppose n size, in this case 1 2 3 4, right? This is 1, okay, 0 1 2 3 and 4. So we are taking 0 based indexing. It will make an array of the size n, or the number of nodes, and it will make an vector coinciding with this array. What I am saying is, it will chain this array and make an vector, and it will make this and make an vector. So this is what will happen using this statement. Okay, now for one we will take, so for one, whether okay, it is representation part. Okay, for one we will check whether one is connected to any other nodes. Yes, it is connected to 2. So one will connect it to 2, and is there any other nodes which one is connected to? No. So now we will go to 2. Now 2 is connected to 3 and 4. We will mark 3 and 4, and for 3 it is connected to 4, right? And for 4 it is connected to 1. So this is how the adjacency list is represented. Now we may ask, how can we represent the weighted graph in case of adjacency list? So for that, what we'll do is, we'll make a vector of int. Okay, what we'll make is, we'll make a pair, and int comma int, and we will make adjacency of n. So what I'm doing is, in normal case, what would I do is, I was making vector of int and adjacency, but in this case we want to take also the weight of that edge also, so we are making a pair. That is the difference right here. Now, so this is what the basic representation of graphs in C++. And now coming on to the DFS, depth first search, DFS. So there are two types of traversal techniques in graphs. So that is DFS and BFS. So another one is BFS, which I will discuss in the next video or upcoming videos. So now I will discuss about DFS. In basic terms, in order to, like, for you to remember it for a long time, what DFS in easy words is, suppose, let's assume that you are a person here, and you are a person X and you want to find a person Y, and there is a tree. Okay, for example, let's suppose you are in a forest, you are X, and a friend of yours Y is lost in a forest, and it has many roads in front of it. And what you will do is, you will take a single road. There are so many roads, but you will take a single road and you will search till the last of it, and if he is not found in that road, and you will come to the next road. So this is what DFS is. But in BFS, what you will do is, so the same thing, the same tree, you are X and you have to find Y, but you will check, for example, there are certain n number of routes here. You can see there are n number of routes here. Okay, this. In BFS, what you will do is, you will, for example, take this road. You will travel 1 kilometer and check whether your friend Y is present in this 1 kilometer. No. You will go to this 1 kilometer. No, no. Yeah. Then next kilometer. So that is how BFS and DFS is the difference. In DFS, you will go full road, and if he is not found, you will go to next road. So that is what. In terms of implementation, DFS is an easier one rather than BFS. DFS is easier to represent in terms of code. So now, okay, there is a thing, how to represent DFS. So this is here. I will show you how to represent DFS in terms, so how to add those things in the adjacency list. Okay, this is how you add. So let me do that in the code. Okay. Okay, so this is what the code is. What I would do is, okay, in order to make a graph, we have to make, I am showing the representation of adjacency lists here. So what I have to make is, I have to make a vector of hint and an adjacency array of, let's suppose, 5 it is. Okay, and I have to do is, so this is the thing. And okay, what I am doing is, I'm taking one. So what is this is, here, let me, okay, here 1 is connected to 2. Okay, and 2 is connected to 3, and 2 is connected to 3, and 2 is sorry, in this case, what I am representing using that code is this: 1 is connected to 2, and 2 is connected to 3, and 2 is connected also to 4. So that is what I'm doing in this case. So 1 to 2, 2 to 3, and 2 to 4 also. So that is what I'm doing. So you can see 1 to 2, 2 to 3, 2 to 4, and 3 to 4, and 4 to 1. So this is the adjacency list representation. Now, in terms of DFS, what I do is, in terms of DFS, okay, in DFS, let's take this graph itself. Okay, first what I will do is, I will take a source vertex. So suppose 1 is the source vertex, and I have to traverse the whole graph. What I would do is I will make a visited vector. I will make a visited array which keeps tracks of whether that element is previously reached or whether it is previously traversed or not. If it is new, then I will mark it as visited, and if it is not new, there is no meaning to traverse it once again. So that is what I am doing. So I will mark a visited of the same n, that is the number of nodes size, and I will initialize it to false at first. After initializing to false at first, I will check if whether an element is reached for the first time. I will mark it as true, and whenever it reaches the second time, we know that it is already reached, so we have to not go there once again. So that is what I'm doing. So this is what, and the first thing, if it is not reached, we have to reach it, and we have to go to all its neighbors. So that is one's neighbor is 2 after, so 1 is not visited, and then one's neighbor is 2, and I will check whether 2 is visited or not. Previously, no, 2 is also not visited. I will mark it as true, and I will check the neighbors of 2. Neighbors of 2 is 3 and 4. We have to randomly, so the code will randomly select 3 or 4, any one of them. Okay, let's take it as 4. Okay, 4. Now it will check whether 4 is previously visited or not. No, 4 is not visited. Then the neighbors of 4 is 1, and 1 is previously visited. So the answer is 1 to 4. And another answer is also, rather than going to 4, it can go to 3, and 3 to 4. So you also should remember that there will be many answers for a graph traversal. For a graph traversal, there can be many different answers. So that is one thing. Here in this case, 1 to 4 is an also answer, or 1 to 3 4 is also an answer. So let's see how to run in the code. So after making this, so let's make it as a global, so that we can get it in the in all functions. And I will make a vector bool of visited, and let it be the size of 5. In global, when we declare it as global, it will initialize to 0 or false. And after making this, after having all these things, what I have to do is I have to write a function, and I have to set the source. Initially, I will call a function DFS, and I am giving 1 as the source. That is, in that graph, I am checking, is there any 1? If there is 1, I will take that node as a vertex, or the starting vertex. I will write void dfs of int, let's suppose this would be source, yes. And then after taking this as source, I have to check if that element is not previously visited. Then only I have to check if visited of that element, yes. If visited element of that element is true, then we have to return. Else what we have to do is we have to make visited of s as true. So if it is not visited previously, we have to make it visited. So that is, we will make it as we will cut the false as true, and then we will print out cout cout s, and let us give a space, and then okay. After making this, we will traverse through its neighbors. So auto it, what auto it would do is, so let's write it adjacency of s. What this will do is it will traverse through the assigned space of that element. So I explained it in this case. Wait a minute, you will understand if I show that. Yeah, in this case, 1 is assigned with 2, and 2 is assigned with 3 and 4, this space. So what that loop will do is it will iterate in this space. Okay, adjacency of s, we will call dfs of it. So that is the thing which is, there is no more than this, nothing more than this. Let me run this, and it should give the traversal here. Okay, 1 2 3 4. So yeah, it was one of the answers, right? You can see it was one of the answers. When you traversed 1 2 3 4, it can give 1 2 4 also, but it would be random manner. Basically, computer will choose the minimum the smallest number. So let us run once again. Will it give 1 2 4 or not? Let me check. No, it is giving the same input. Let us remove this. Okay. So rather than giving 3 to 4, let me give 3 to 2. In this case, what I am doing is I'm not giving this and I'm giving this. In this case, either it should give 1 to 3 or it should give 1 to 4. Let's check what the answer would be, right? It should give 1 to 3 or 1 to 4. What the fuck? Okay. Yeah. See, it is giving 1 2 3 4. I think I'm missing something. 2 to 3 and 2 to 4, right? Okay, okay, okay. It is traversing on this thing. See, it is giving 1 2 3, right? So this can be one way, and there are many ways to traverse in DFS. So that is it for this video, guys. Thank you so much for holding this much long. Thank you. Keep supporting.